Kuhu.
Yeah, I started recording.
Okay, good.
Okay, hi everyone. So we have Dr. Sungjin Ahn here. I actually took a class with him last semester, and he's going to be chatting with us about his various experiences. So, Dr. Ahn, do you want to start off by just like introducing yourself?
Yes, so I'm an assistant professor of computer science. So I joined Rutgers like 2 years ago from 2018. So it's been like I'm doing my third year here. And before I'm joining here, I did my actually bachelor and master's degree from South Korea, and then I came to the U.S. for my PhD, and I did my PhD from UC Irvine. And I went to Montreal, Canada to do my postdoc, and I spent like 2 years there. And then before also joining Rutgers, I also spent 1 year in a company, AI company called Element AI. And my research is about mostly machine learning, and yeah, so yeah, that's me.
Okay, awesome. So, first, we wanted to start off and try to get to know who you are outside of being a professor. So, what are some of your interests outside of computer science and teaching?
Yeah, so outside of my this professional life, I have two kids, like 2 and 5 years old. So mostly I spend time with them. Most of the majority of my time is about research and work. And so when I have some time these days, I spend most of time with my kids. And if I have more time, I also like to reading some books about brains and AI, and also sometimes I also enjoy some K drama. So yeah, if I have some time, I also enjoy watching some K drama from Netflix.
Awesome. I have a quick question. Do you have any books that you recommend us to read?
Books, yeah, actually there are lots of books. So let me see. So usually what I read usually is like research papers. They are like trying to solve a very specific problem very technically, but some of the people need more like a broad, like a holistic perspective about this problem of AI and brain. So one book I recommend is by uh, Jeff Hawkins. The title is On Intelligence. I actually have that book here. There's something. This is the book. So this book is about so the spectrum of neuroscience is very broad. So some neuroscientists are not very much interested in making like a human-like artificial intelligence, but some small, portion of neuroscientists are actually very interested in also like making a connection from neuroscience to making a artificial intelligence machines. So this book, I think this guy is actually one of those researchers who try to do that. And and about the brain, or let me just try to see my. Yeah, I also enjoy sometimes like this kind of neuroscience book that has like lots of pictures about the brain. So yeah, if you want to make a connection, actually this the title of the book is The Human Brain Book.
Who's it by? I'm like writing this down right now because I'm very interested.
Yeah, Rita Carter.
Okay.
And
awesome.
yeah, actually maybe at the end of the podcast, I can actually provide you some list of nice books. I can come up with the full list of the books, but I'm sure that I have like a bunch of very interesting books that provide kind of interesting overview of the field. Oh yeah, there's another book I remember the title is just uncertainty, surfing the uncertainty. So I think the author is uh, I forgot his name, but he's a British professor of philosophy, but he's also working on the AI problem as well. So you may find the book from Amazon. The title is like a surfing the uncertainty, something like that.
Yeah, I just looked it up and I added all 3 books to my Amazon cart. I think it's by Andy Clark.
Yeah,
And
Andy
the reason
Clark.
why, yeah, and the reason why I was asking is because I know a lot of us on the call are considering pursuing cognitive science degrees, or we're also like, I know me and Deepika are cognitive science double majors in addition to our CS degree. So I just thought it would be interesting to get your take on that. I do see that we have some questions about your favorite K-dramas, and Jarell asked if you've seen Crash Landing on You. I've seen that, by the way.
Oh, Crash Landing on You. Oh, yeah, maybe I don't know the English title of the K-drama, but I guess yeah, I'm not sure
It's,
if I know the Korean title of that thing.
I don't remember what the Korean title is. My cousin was it's very interesting. I have I call him my cousin, but he's Korean. And he told me the name of it, but basically it's the one about the girl from South Korea who goes to
Uh-huh.
North Korea, and she like falls in love
Oh,
with the soldier. But yeah.
yeah. I haven't watched this one, but I just searched it. Uh, yeah, but I think I'm told from my friends that this is very uh good one. So yeah, if I have time, I will try that K drama next
And
time. So one,
another
yeah.
like, oh sorry, I was gonna
Oh
say,
no, bro. Go
I
ahead.
think you were gonna actually answer this, but I was gonna say Manasvi was curious about what your favorite K-drama is then.
Oh, my favorite K drama. Actually, I think I have watched one series very recently. The title is My Mister. So that is available in Netflix. So I am My Mister. Yeah, this is actually I really liked this one. I for like about 2 weeks I cannot like I'm kind of swamped with the atmosphere of the K drama, and I really loved it. It's kind of one of the best I've ever watched it. It's also very not kind of one aspect of it is very dark, but the other aspect is also very I mean very hopeful and very bright thing, and lots of very good people, story about very good people and their relationships. So I really love that drama.
Awesome. That was great to hear about. We also wanted to know, how did you get interested in computer science, specifically AI?
Yeah, computer science first. Actually, I didn't have much thought when I need to decide which major I'm gonna have. So actually, my father just suggested me that like this electric engineering or computer engineering, computer science, this field are like just good. You can find a good job there. So I just went there. And in my first year, actually, the major was not decided. So I can choose my major from the second year among computer science and electrical engineering, and also some kind of information technology, things like that. And then in my first year, I took some programming language course. It's basically about C language at the time. And I just felt that I'm enjoying it a lot. And whenever I do programming, I just guess. I mean, I don't know how the time goes. So, and then I felt that like the other class is about like making some electrical circuits. And I found that I really hate handling or playing with some hardwares. So I'm kind of more, I found I'm kind of person who likes more mental thought than like actually working with some visible hardware things. So I decided to go to computer science, and I'm pretty satisfied with that decision. And then the second question was about how did I decide to go to AI or work
Yeah,
on?
specifically AI.
Yeah, AI. Yeah, so it was like about 10 years ago when I was doing my master's degree. And at the time, the AI was not that much hot like these days. So, but at the time, this company Google was very like hot in South Korea, and that's mostly about the story about search engine and things like that. And then I was so interested in, and I began to like search about the technology, and I found kind of behind all this technology, the core is about the learning algorithm, the machine learning thing, and I'm also kind of have a fantasy as a kind of liking. I mean, this sci-fi kind of story. So someday we will have like this kind of humanoid robot, and we can maybe have a some chat with this humanoid, and that kind of sci-fi. Um, I mean, how can I say? So uh, my personality, who likes this kind of story, also made me pursue uh, me to choose this direction. Yeah, so yeah, when I first decided to do work on machine learning, at that time a friend asked me, "What is machine learning, and why do you do that thing at that time?" So at that time, that was not very much popular. But since I started the research, my PhD in AI, just a couple of years later, it became very popular.
Got it. So I guess to follow up, what made you go into academia and research?
Yeah, yeah. I think first of all, um, I mean, to academia, yeah. I during my PhD years, I really enjoyed working on this research problem, also kind of long-term problem. So the reason initially, I think when I came to the US for my PhD, initially I thought that maybe after graduating PhD, I may just get a job from a company like Google, Facebook, something like that. It's a pretty good job, right? But when I do my research, I found it really interesting, and it's worth, um, I mean, doing this kind of fundamental research for the rest of my career or longer term. So I decided to do postdoc, and then, uh, yeah, decided to go to academia. And luckily, I got this position from the Rutgers University.
Okay, awesome. And I guess like another question I wanted to ask, picking back of what you were talking about is I know a lot of people these days, especially undergrads, want to go into like AI and machine learning, but
Mhm.
something that a lot of people say is that you need to have like a strong mathematical background when pursuing an AI career. So,
Mhm.
what are your thoughts on that like sentiment?
Yeah, yeah. So that's very good question, and yeah, it's yes. Definitely having strong math background will help a lot. Um, but even if you don't have strong math background, but fundamental math like basic calculus and linear algebra should be enough for some areas. Maybe not enough, but yeah, yeah. So this area of machine learning is very broad. So some specific area of machine learning is very mathematical. They are dealing with kind of the same level of like maths, like mathematicians. And the other area, more applied area, there's also very interesting problems there where the demand on the hardcore math is not that, I mean, hardcore. So there's some spectrum, and but if you have a strong math background, you have more freedom to choose what problem you are going to work on. If you don't have like much, I mean, knowledge or technique dealing with mathematical concepts, then maybe your problem set you can work on could be limited. But if you have good math background, you can work on more applied thing or more fundamental problems. So, and it also depends on your career goal. If you want to have like a very long-term research career in AI research, then I would definitely recommend to build very strong mathematical background and knowledge. But if your goal is maybe having master degree or just finish after finishing PhD, you want to go to industry and you want to get a good job in and work on some kind of practical problems in these big tech companies, then um, yes, even if you are not very deep at math, it's still uh, doable, I think. But I would recommend keep uh, uh, studying math and keep trying to improve your math skills. And another important part is it's not only about knowing like a breadth of mathematical knowledge. So some people maybe who major in math and they know um, calculus, linear algebra, statistics, real analysis, differential equations. So there are lots of different fields. So someone who may be very strong in the breadth, but I think what's more important is the depth or deep understanding of those mathematical concepts. So even if you are familiar with the linear algebra and calculus, and I think linear algebra, calculus, and probability or statistics, these three are the core math topics that you should be very familiar with. And not just taking a course, but having this mathematical knowledge is something really at the level that is really working, which I mean, you may maybe build you can do some modeling, given some problem, you can do some modeling using this concept. So that kind of deep understanding of this core concept is basically actually very important, I think. So yeah, one example is one of the most prominent, most famous researcher in my field is Professor Jeffrey Hinton in the University of Toronto. And his paper is not that much mathematical, but it includes really deep understanding of the core concept. And using that deep understanding of the core concept, if you really understood things very well, then you can devise or model some very simple equation, not very complex proof of some theorems that is maybe not very necessary in designing a new model. But if you have very good, deep understanding of the core concept, then I think that would be very helpful for you guys to later develop some new model.
So, picking off of that question, I feel like a lot of computer science majors, they're just expected to take Calc 1, Calc 2, Intro to Linear Algebra, and that's usually like where they stop. And there are classes that like some of us take like Calc 3 and probability theory to like learn more about it. But
Mm.
you mentioned like trying to learn math outside of your classes. So what are some ways that like we can do that?
Yeah, I think once you have a grasp of the basic concepts by taking courses like linear algebra and calc and statistics, then I would suggest to work on actual some research project. So that will help you or give you some chance to read some academic papers. So by reading papers, actually the papers containing actual application of those mathematical concepts, how those mathematical concepts can be used to solve actual machine learning problems, right? So for example, to linear algebra is all about like this matrices and how to do the matrices. But if you work on some computer vision problem, then you learn how this image and pixels, how those can be actually modeled using these matrices and the tools of the linear algebra. And then if you also work on some real problem, then you realize that the real world contains a lot of uncertainty. So it's not always a deterministic system. Given some input, the output could be stochastic, and random noise is included in that problem. So if you work on that kind of problem, then you also know how this probability theory can be applied to solve this kind of problem. So yeah, I think the best way is to work on actual research problem that will give you chance to read many papers about how to use that math concept to model machine learning problems, and also the chance to implement things and getting also the knowledge of the state of the art progress of the field. Yeah, that's it.
So to follow up on that,
Mm-hmm.
what majors or minors do you recommend students pursuing if they're looking into AI?
Yeah, so to me, yeah, actually, yeah, that's very interesting question. So as a father of two kids, and I cannot uh, like insist, but I have some kind of hope that one of my or my kids to have this career in AI. And if they want to do that, then I can advise them which major or double major they are gonna choose. So I sometimes think about it, and yeah, maybe computer science. I think always the base, and then computer CS plus math or CS plus physics is also I think a nice combination between math and physics. Uh, so I like actually physics a lot because physics is about physicists they use math as a tool for modeling the phenomena of the universe, right? So they don't care much about the mathematical rigor, like proving things very rigorously. So that's what mathematicians do care a lot. And to pursue that mathematical rigor, things sometimes become unnecessarily complex. So if you want to do do mathematical analysis of some mathematical model, that is what is required. But in many cases, what we want to do in machine learning is we want to devise some new model using math as a language. So you can think of it like developing a new machine learning model as a like uh, writing a good novel, right? Very interesting and a novel that is very intriguing and fun to read. And to write that kind of good novel, you don't need to be a linguist, right? You don't need to study the linguistics itself. You just need to know how to use the language very well, very fluently, and in a very explicit way. So that's what I see physics. So physicists know how to use math to devise something new, some kind of new modeling to solve some new modeling problem. Sometimes it requires some kind of mathematical proof as well, but it's not as rigorous as the what the usual task of what mathematicians do. Whereas mathematicians usually pursue more abstract and more mathematically rigor um, approach in dealing with this mathematical problems. So uh, from that sense, I think of physics. And here, when I recommend physics, the knowledge about the physics itself, but the knowledge of gravity or knowledge about like the universe or how these atoms behave. This kind of domain knowledge is not the interest to us if you are interested in studying in AI. But the way the physicists use math to solve that problem of how to model the behavior of atoms and like gravity, things like this universe, principles of the universe, how they use math to solve that problem is kind of similar for us as a machine learning researcher or AI researcher to use math to solve the problem from using data observations. So in that sense, physics provide also very good, I think, complementary principles and skills for to machine learning researchers. So yeah, those are two CS plus physics or CS plus math. And if you are not very familiar, you find that I don't like maybe math, or really have some trouble in dealing with that kind of deep math. Then I think that's totally fine. So there, as I said, there are lots of different spectrum in doing AI research. Then I suggest maybe doing double major or minor, taking cognitive science or neuroscience. So that combination also will help you have some unique perspective. I mean, approaching the problem of AI. So um, in yeah, AI problems or machine learning problems, it's not always some researchers approach the problem purely as a mathematical problem. So they don't care about like biological plausibility in pursuing the approach. They don't care about whether it is similar to how human brain works or not. But some other area or party of the researchers, including the deep learning researchers, pursue the like some level of biological plausibility and try to get lots of intuition and um, intuitions from how actual human brain works, the structure of the brain, and how what kind of representation the brain develops, and how they transfer the information, things like that. So I think that combination CS plus psychology or neuroscience is also a good combination, I think.
Thank you for sharing. Those are very interesting. And I like how you talked about physics because
Mhm.
this past summer, I actually interned on an ML research team, and everyone on my team had PhDs in physics, which I
Mhm.
didn't really like know about before.
Mhm.
And for like the same exact reasons that you mentioned, I feel like the way that they apply math to their models is
Mhm.
something that I guess my manager thought was very unique. And also,
Mhm.
I feel like pursuing physics in general is just very hard. Like everyone
Mhm.
knows that
Mhm.
if you like get through a physics like PhD, for instance, like
Mhm.
you can kind of like do anything. That's what my that's how
Yeah,
they kind of described it.
yeah.
But yeah, actually I wanted to kind of transition over to your PhD experience. So the first
Mhm.
question I had was why did you decide to pursue a PhD in computer science?
Yeah, yeah, this is related to, I think, part of what I have already answered. So, first of all, I just want to come to the United States from my um, like young age. I was grown from South Korea, and some drama or movies I watched about the campus in the United States, and I think I just kind of admired the kind of life in the US as a student. So yeah, that's one reason, and yeah, that's part of the reason. And also, I wanted to do uh, work on the field of AI. So my master was in CS, but I didn't specialize my research to AI. So it was kind of to me also a career change within CS. So that's why I did PhD, and the purpose of the PhD, doing PhD initially, I think it was open. I could have thought that I might take the industrial position, or if I do the research well, I may also take the academia position. So it was open, and I finally, at the end of my PhD, I decided to pursue academic position.
Awesome. And my next question is, I know that you, as you mentioned, you received your PhD at UC Irvine,
Mm-hmm.
and your thesis was on scalable approximate Bayesian inference under Professor Max Wheeling. What does that mean?
Yeah, so at that time, the main topic, this is in the field of AI. So the main theme is like a deep learning, right? So or catchphrase is mostly about people, or people talk about deep learning. At that time, it's before this explosion of deep learning. Before it's just a very early version of the deep learning, because it was from 2010. So, but at that time, what was very hot was the big data. So yeah, at the time, these big tech companies began to collect lots of data, and then they realized that if we can analyze this data well, then we can make some new products, and we can improve the performance of our services, or accuracy of our services. So this learning from big data is the main big theme. And before that, machine learning algorithms, many of the machine learning algorithms were not scalable, because usually it was applied maybe some small amount of data. So it's still slightly better than the typical statistics tools, but it's not at the level of that can deal with like billions of data points. So and this in machine learning, there are two, maybe very roughly, I can split the approaches into two approaches. One approach is Bayesian approaches, where we do care a lot about the uncertainty in our modeling. So in Bayesian approach, we consider everything is like stochastic random variable. So the world is a stochastic random variable. So we should do probabilistic modeling. And the other party, they maybe don't care much about this uncertainty, so they can assume that things are deterministic. So they can model the world or phenomenon as a deterministic model. So in the field of a deterministic model, there was a good approach making the model scalable. But in this field of probabilistic and Bayesian modeling, we didn't at that time have a learning tool that can scale to like millions or billions of data points. So that making this Bayesian or probabilistic machine learning methods scalable to this scale of large data set, industrial scale large data set, was the mission of my PhD thesis. And to do that, I developed and proposed some of the efficient learning method. Yeah.
In addition, we were also wondering what your favorite memory was while pursuing your PhD.
Yeah, my favorite memory, yeah, there are many. One, actually, yeah, this is I got like the best paper award in one of the most prestigious machine learning conference. So in my second year of my PhD, so that was yeah. Actually, when I first got the email from the conference that you are selected as the winner of the best paper award, that was kind of, I could say, the best moment. Yeah. So I still sometimes open the email and then read it.
Was it the ICML conference?
Yeah, that was the ICML one. Yeah.
Okay, cool. Yeah, well, congratulations. I feel like that's so fascinating to hear you say that you open up your emails to see like your past accomplishments. Because sometimes when something happens, nothing that I feel like nothing in my life has happened that's like as like
Mhm,
impressive as getting like the best paper award at a conference like that. But
mhm,
sometimes when things like that happen, I'm like, wait, someone pinch me because I feel like I'm
mhm,
dreaming. But
mhm.
I actually had a quick question about your PhD experience and coming up with your thesis because someone once told me that if you're going to pursue a PhD, pursue it in something that no one believes in yet.
Mhm,
Because I feel like there's a lot of people that are pursuing PhDs in computer science like all over, but
mhm.
whatever you study like in your thesis needs to be something that like I guess like is going to be the next big thing. That's at least like the advice that I got. But
Mhm.
what are your thoughts on that? Like, what do you think is going to be the next big thing? And if people are thinking about pursuing PhDs, what are those like cutting edge areas you think that they should kind of like look out for?
Yeah, yeah, that's very interesting question, and also I think it's a very difficult question. Yeah, so yeah, I don't know. I think you said you are mostly like a first or second year undergraduate student, and when you start maybe your PhD 3 or 4 years later, I think the field will be already changed a lot. So I cannot like imagine what would be um, the most important topic specifically, but maybe more broadly, um, yeah, one very big problem is uh, currently this deep learning or most of the deep learning models working well, it relies on this specific way of training it using backpropagation. So that is basically gradient descent applied to the neural network, a way to compute the gradient through some kind of chain rule, this nested functions. And this is, I think, the reason why it's working so well currently, but it's not very biologically plausible. And I think it's the backpropagation learning algorithm is kind of the upper bound what we can do. But the current deep learning system also has some limitations. First, maybe not very modular. So meaning that some concepts, for example, for us to humans, if we learn some concept about some object, right? Maybe the water bottle or about the laptop, that is kind of modularized concept in the sense that even if I observe that object in a context, I observe my laptop in the context of my office, a specific background tone and with other object, I have still have the modularized and independent understanding or knowledge about what this laptop. So if I found the same laptop at my home, in a totally different context, I can still understand what it is and how it works. But in current deep learning model, this kind of modularity is not achieved. And due to the lack of this kind of structure, not satisfied within the deep learning model, it also suffers from this problem of catastrophic forgetting, which means if you don't observe some data for a long time, the model forget about that thing. But we humans, I think we still remember, I can still remember maybe some experience that I experienced like 10 years ago. And since then, I have never visited maybe some places again. But I still have the memory about that experience. And if I revisit that place, maybe you guys have kind of similar experience and you come to some place, some town, and you just realize, oh, I was there like 10 years ago. And there should be, if you turn to the right, there should be some kind of maybe ice cream store there, things like that, right? So we don't suffer from this catastrophic forgetting problem, but current deep learning model suffers from this problem and we don't know how to solve it yet. And I think maybe this problem is related to the solving also the, I mean, coming up with a better learning algorithm that is better than backpropagation. And in brain, our learning algorithm is also local. It learns locally through the interaction with other neurons, right? But in current deep learning model, we do forward pass, and in the end, we compute this loss function. And the error in the loss function is somehow this global loss function needs to be backpropagated to all the neurons, right? So this is global update. If you don't, it's not local update. So that is a fundamental difference between how human brain learns, how the learning mechanism of the neurons in mostly in the neocortex, and what the current deep learning model is doing. There is some perspective, some feedback connection in actual in the brain that may the interaction between this feedforward and feedback connection somehow implement implicitly this backpropagation algorithm. But I think this is one of very fundamental problem in machine learning. Yeah, I think mentioned one very big problem.
So we also wanted to know, what should undergraduate students hoping to pursue PhDs be doing in college to prepare for applications?
For applications, yeah. So what I found, and also as a professor uh, who is looking for PhD student every year, um, yeah, what is really important is the actual experience of doing some research project, potentially with publication record, because that tells a lot about the student. So that means basically the student can immediately start working on actual research project that will lead to the publication. So, but I also at the same time understand it's not easy. As an undergraduate student, you guys are taking like lots of courses, and it's difficult to make a time to devote to some extra project, especially for actual project. A paper project, it requires a lot of energy and time to run experiments. So it may, I think, uh, for one single person to do run or to lead some research project, I would say the workload maybe taking like 3 courses or 4 courses just to do one research project. That's what each student are doing here. So yeah, if possible, I think during undergraduate years, I would suggest maybe taking lots of math courses or some neuroscience, or so you build very strong fundamental, because it's also not easy to self-study this kind of mathematical courses later. So that, and then if possible, maybe you can pursue master's degree, or even not taking master's degree, or if you can just spend like 1 year as a research intern in some lab, and spending your full time 1 year for some research project, then you may have some publication, or at least you will have lots of experience, and that somehow proves to the professors that you are kind of ready to jump in to the research project. I mean, in a short time, you do, and then also I think it would be also helpful for you to check yourself whether I'm really good at doing this kind of career, having this kind of career, or if this kind of like a life as a researcher, like programming and reading papers, this is like a good fit to you. I think it is actually a good experience. So because these days, this area of AI and machine learning becomes very competitive. So most of the PhD students getting the offer, most of them already have master's experience or this kind of research internship experience, and they mostly have one or two publications. So yeah, so having that kind of getting that kind of ability is, I think, or experience is something very helpful.
So you talked a little bit about the master's program, and I was wondering if you see any value in students pursuing an MS and CS before applying to PhD programs.
Yeah, I think it's basically in the same uh, sense I explained. It's not mandatory, but you can consider it as a good opportunity uh, to have some research experience. And I think actually, if your final eventual goal is have going to the for PhD study program, then I don't think having actual master degree, I mean, getting the degree itself maybe not necessary, because to get the degree, you need to study 2 years and you need to take also lots of coursework. You need to do lots of coursework, and also you need to spend tuition. So that's, yeah. And you may still have, so I think the most important experience is like a publication and actual research experience. But having master's degree, I think it will give you kind of put you kind of similar setting what you already did during undergraduate student. You still need to take lots of courses, and then, but you may have more time, so you can um, do the research project with some advisor. But if I'm the one who chooses or who try to give an offer to the applicant, and one student has master degree and took some more courses, and but doesn't have much publication or actual experience of implementing models and running experiments. And there's another student who just did finish the bachelor, but spent 1 year in some lab and spent the whole year fully um, working on some actual research project. I would, and then if he or she has some publication or near publication result, I would prefer the other student who have the has the actual hands-on experience and skills.
And I have a quick follow-up to that. So
Mhm.
for students who don't intend on getting a PhD, they just want to go straight into industry, do you see a value in them pursuing a master's in CS when they're already pursuing an undergraduate degree in computer science?
Uh, yeah, if after having the master's degree, if the goal is to go to industry, I actually don't know. I think in that case, I think the only factor you want to see is whether having this master's degree increases the like probability of getting the offer from the company, right? So it may depend if the master's degree is from very prestigious school like maybe MIT or Stanford, then that may be helpful. Um, and but I think most of the tech company, their interview process is mostly most important factor is like actual like a programming interview. So they want to see actual the ability, technical ability. Maybe there might still some factor affecting the decision. Maybe if it is very well-known good university, but I think that may not affect much. I think your actual programming skill will be more important, and after getting the offer, the remaining career, I think having master's degree or not also not affect much.
Okay, awesome. And I have a quick question about your postdoc experience. So
Mhm.
my first question was, what is like the purpose of a postdoc? Is that like something that you do to get into like the academia track, or is that something that everyone or like a lot of people just typically do?
Yeah, people have different intention and purpose of doing postdoc. Um, so it's not mandatory thing to get a faculty position in the field of CS. But in my case, my specific case, my PhD topic was about this scalable Bayesian inference. And when near my graduation, this field of deep learning became very popular and very important in my field. And also my PhD topic is a little bit more like a fundamental, like theoretic thing. And I also wanted to do more like applied thing, like working on images and languages and actual more kind of not only mathematical fundamental tools, but I want to make a kind of a more, yeah, the models that I can enjoy more. So actually, that's why I decided to do my postdoc, basically to have some experience in deep learning and to work on other problems that include some video, image, and language, things like that. So I'm very much interested in like building human-like AI machines inspired by cognitive science and neuroscience. So that was my goal because the University of Montreal, the Professor Yoshua Bengio, is someone who can guide in that direction. So that's why I did my postdoc. And yeah, for some other people who do postdoc, they may just want to uh, publish more because if they feel that my publication record or after finishing my PhD may be good, but it's not strong enough to apply for a faculty position, then they want to do postdoc. And yeah, one difference, usually postdoc, um, the advisor or the supervisor of the postdoc position give more freedom. So during PhD, you are more tightly advised by the advisor in choosing the topic or the approach. But as a postdoc, you become more independent and you can also explore some other problems like what I did. You can try to broaden a little more about your research uh, area during the postdoc years. So I think, and also the networking, social networking is also important to you if you're gonna be faculty. Then, yeah, by doing postdoc, usually postdoc you try to go to a bigger or higher level university, so where you may make some network to very well-known professors or some other PhD student or other postdocs who will later become your colleagues when you became a professor. So that's also very, very important um, uh, purpose of doing postdoc, possibly.
Okay, awesome. And I have like two final questions. So the first
Mm.
one is, what is one piece of advice you have for seniors that are graduating this year? This is kind of just something that I want to gauge. I don't know if anyone else cares, but any
Yeah,
advice for undergrads?
yeah, yeah, I think I read I wrote something about this from your question list. Uh, yeah. So okay. Uh, yeah. So yeah, I thought about this question and I somehow wanted to say something other than the technical thing. So looking back my undergraduate uh, times, I think so. I may could say to make a good memories with your friends because those memories and the time you spend with your friends, it seems just natural when you were there. But if you, I mean, 10 years later or 20 years later, it becomes really important asset of your life. So when sometimes you will have like some difficult time, some tough time in your life, but at those moments, like having some friends to talk about your life. We did like testing when we were undergraduate students, and those memories and those moments are, I think, very, um, I think, good asset throughout our life. And also, I think pursuing your goal, like you, maybe some of you guys want to do a AI researcher or want to be a professor in machine learning or cognitive science, but I think it's of course really good to pursue that goal and dream. But I want to say that like the happiness is not only there. So in lots of different aspects of our life, there are lots of different um, way we can be happy and we can find the values. So I myself maybe spend lots of time just pursuing my goal. Or I want to become a better researcher, and I need to study harder, and so maybe I may not spend enough time, or I didn't look around my other values or other ways of being happy or sharing the happiness with others. But I think um, that is also very important thing. So not getting, I think if you have taken like the course of machine learning, this concept of like overfitting. So this maybe stochastic gradient descent optimizer. If you just try to minimize locally, then it falls in this local minima. But actually, there are lots of other very good solutions nearby the local minima, right? So um, it's good to pursue this direction of your goal, of your dream of your life, but at the same time, not just overfitting too much. In the sense that may like give you too much stress and you see very narrowly things. But I mean, seeing your friends and spending time with your friends and families, and also pursuing your other hobbies. I think those are all, I think, very important uh, thing, something I could say, because I know everyone will work very hard for your dream, right?
Yeah, thank you for that. That was such a great way to close off today's
Mm,
session. I love that. Like that, I wrote it down, the little quote about don't overfit your life, because I feel like I'm guilty to that sometimes, and I want like I want it to fit 100% to my training data
mhm,
set, but it's not gonna
mhm.
perform well with
Yeah.
like my actual. But
Mm,
yeah, I guess that's kind of where we're gonna close off today. Thank you again for sharing all of your advice and answering a lot of our questions. So why don't we all give Dr. On like a little virtual applause?
yeah.
Okay, yay.
Thanks a lot for inviting. I really enjoyed this podcast session. Yeah.
Thank you. We loved having you. I think your perspective was so interesting because
Mm,
I feel like a lot of undergrads just want to go into industry, and not a lot of us talk about like PhDs, masters, like how do you get there? So I think your
mm,
perspective was so unique.
mm. Thank you. Yeah, I hope you guys enjoyed, and my advice was helpful.
Definitely was. Thank you
Thank you.
again for
Okay.
joining in, and thank you everyone for